Okay, we're going to finish up number 7 here and then go on to page 5 into the last two problems. A cable TV receiving dish is in the shape of a paraboloid of revolution. Find the location of the receiver, which is placed at the focus if the dish is 6 feet across at its opening and 2 feet deep. I put a picture here, but it's a little bit hard to see what's going on in here. So what we're going to do is kind of take a cross section of this and look at that parabola before it was spun around. So let's go ahead and sketch a graph. And you can put that parabola opening whatever direction you want, and you can put the vertex wherever you want. It's generally easiest if you put that vertex right at 0, 0 and have this parabola opening upwards. A little bit easier for us to think about. Now, I'm just erasing here because this dish is actually right here because it stops. I mean, the parabola keeps going, but the dish itself doesn't. And we know that the dish is 6 feet across at its opening. So that distance, 6 feet. And it is 2 feet deep. So we need to figure out where the focus is. Here's the vertex. Focus has to be in here somewhere. We're not exactly sure where it is, but that's what we're looking for. Where is that focus? Well, we can set this up. This is a parabola opening upwards, so we know it's in this form. Y equals 1 over 4p times x minus the vertex, which was 0, 0, so 0 plus a 0. And simplifying here, to solve for p, once we know what p is, that's the distance from the vertex to the focus. We can use this information that this is 6 feet across and 2 feet high. So at this point right here, the coordinates there have to be 3, 2. Plugging that information in. And we can go ahead and multiply by 4p, which will give us 8p here equals 9. P is 9/8. That's the distance from the vertex to the focus. So we can say that the receiver, or the focus, is 1 1/8 foot from the vertex along the axis of symmetry. The focus is 1 1/8 feet from the vertex along the axis of symmetry. Okay, there we go. Let's move on and look at number 8. All right, number 8 says that we have a sealed beam headlight is in the shape of a paraboloid of revolution. The bulb, which is placed at the focus, is 1 inch from the vertex. If the depth is to be 2 inches, what's the diameter of the headlight at its opening? All right, now what we can do in this case is, because it's kind of facing sideways, we can just superimpose an x and a y axis right on top of this. There's a y-axis, and let's put the x-axis right here so that we see the vertex of this parabola right at 0, 0. All right, and let's see, what do we know? The light bulb, which is placed at the focus 1 inch from the vertex. So here's the vertex, there's the light bulb right there. There's the light bulb, and it is 1 inch. 1 inch there. The depth of this light is to be 2 inches. So the light's actually on a little bit of an angle here, so we have to kind of imagine this. The depth of the light is going to be 2 inches. And we want to know what's the diameter of the headlight at its opening. So we want to know how tall is it across here. All right, looking at how this paraboloid is set up, our parabola is opening to the right, so that's an x equals 1 over 4p. Vertex is at 0, 0, so we can just realize that that equation has to be x equals 1 over 4p times y squared. And in this case, we know what p is. Distance from the vertex to the focus is 1, so we can put that in. Because p is 1. All right, now, goodness, let's see, what could we do here? Oh, let's find out what happens when x is 2. When x is 2, that'll give us this top corner up here, 2 comma something. And once we know that height right there, then we can get this height and we'll have the diameter. So let's see what happens when we plug in 2 for x. So 2 is 1 over 4 times y squared. 8 is y squared. So y is plus or minus 2 square root 2. So this point up here is 2 comma 2 square root 2. And down here is 2 negative 2 square root 2. So the diameter is 4 square root 2 inches. All right. Moving on to this last one here for section 10.2. A mirror shaped like a paraboloid of revolution, or is shaped like a paraboloid of revolution, and will be used to concentrate the rays of the sun at its focus, creating a heat source. If the mirror is 20 feet across at the opening and 6 feet deep, where will the heat source be concentrated? Okay, just take a moment and think about this. A mirror is 20 feet across. That's huge, and 6 feet deep. So if you're standing at the bottom of the mirror and you are 6 feet tall, your head hits the top of the mirror. You can't see over the top. If you're taller than 6 feet, a little bit taller, maybe you can see just over the top. If you are shorter than 6 feet, your head doesn't even reach the top of the mirror. I don't know if you can tell very well by this picture, but they're actually showing a steak sitting on this grill plate here. They're trying to cook a steak using sun. Okay. This picture is actually very nice because we can superimpose a y-axis. So I don't know if you can see that green very well. I'm going to use a different color. We can superimpose an x-axis and a y-axis right on top of this graph. And we very definitely see this mirror in the shape of a parabola here. Okay, 20 feet across, 6 feet tall, means that this point right up here, that edge, has coordinates 10, 6, and we are wanting to find out where does the heat focus, or where are we going to cook that steak? We want to find that focus. So ultimately we need to find this distance, this p value. When we set up this equation of the parabola, we have y equals 1 over 4p times x squared, because we put the vertex at 0, 0. We don't know what p is, but again, like a couple of problems ago, we do know this coordinate 10, 6. If we substitute that in, I'm going to multiply by 4p. That's going to give me 24. P is 100. Divide out the 24. And simplifying here, we could divide by 4, top and bottom. So P is 25 over 6, which as a decimal, that is 4 1/6, which is 4.16 repeating here. But we don't like to use repeating decimals. We like to go to at least 3 decimal places, so let's drop that off. All right, so that's it. Where's the heat source? The heat source will be concentrated that many feet from the base along the axis of symmetry. The heat source will be concentrated .166 feet from the base of the mirror along the axis of symmetry. Excuse me. Let me move it up so you can see what I wrote. Excuse me again, I'm sorry. Okay, there we go. Thank you.